When analog system designers explain what they want from their design tools, it can seem a little bit like that story of the blind man and the elephant. You know, the one near the trunk says an elephant is like a rope, and the other one near the legs says, no, an elephant is like a tree. And the one with hundreds of independent complex simulations to run says, no, an elephant needs to be able to launch and monitor many jobs. And the one with the tough design problem says, no, an elephant needs to give me interactive control of my simulation. Wait, I think I might be mixing things up here. The real elephant in the room here is that every member of the team has different needs and requirements from their analog design tools. Hi, I'm Amelia Dalton, host of Chalk Talk. After working for years with hundreds of design teams, Cadence has done a major change to their Virtuoso analog design environment tools, and absolutely no elephants were harmed in the process. My guest today is Steve Lewis from Cadence Design Systems, and we're going to dive into the new ADE and see how it can help your team get untangled from today's tricky design challenges. And before we get started, don't forget to click that link. There you can find out more information about Cadence Design Systems' Virtuoso ADE product suite. Hi, Steve. Thank you so much for joining me today.
Thanks, Amelia. It's fun to be here.
So on my design team, different people have different roles, of course. And sometimes we find that the tools we have are only useful for certain members of my team.
Right. And in fact, that was one of the things that we took into account as we were sort of developing these brand new analog design environment tools. Cadence has certainly been doing this for a long time, but we had an opportunity to kind of take a step back and really look at the users that were out there and how they wanted to use the product. So when we did that, we kind of found that there were three basic types of engineers.
Okay.
The circuit engineer, the guy who's trying to get his design off the ground, get it working, trying to get the waveforms to wiggle, that sort of thing. The guy right at the beginning of the design.
Yeah.
And then there's typically a guy who comes later. Now, sometimes it's the same guy, sometimes it's a different guy. But it's the person who now has to make sure that they test that circuit in a variety of different conditions. Could be environment. You could be shooting this thing into space. You could be putting it down into the ocean. You need to be able to test all of these different environmental conditions that your circuit might find itself in.
Sure.
And then there's this new guy on the block, and it's not so much a new guy as it's really an idea that is really coming to fruition, I think, in the analog domain space. It's something our digital brothers have been doing for a long time, and the concept is, how do I verify that all of the pieces, the moving parts on my analog design, are actually coalescing, how they're coming together?
Right.
Right now, people either have to email each other, or maybe they leave a mean voicemail yelling at somebody, or maybe they've got an Excel spreadsheet that they're hoping everybody is keeping up to date, but that's not really a very satisfactory way of being able to verify that all the pieces are coming to the main end of the project. We have to get the product out for us to then make the money to get to the next project. So really it is verifier, or the verification product and the verification engineer, that is, I think, going to be most pleased with what they see in the new products, because there's going to be something just for them.
Excellent. Okay, so what are these products?
Well, if we take a look at them, there are really three main pillars to the brand new world. One is called the ADE Explorer, and this is really for that guy at the beginning, the circuit designer, who's trying to get things going. He's kind of wanting to do interactive sorts of things. He's looking at performance. He wants to make this thing work, and that's really what the Explorer is all about.
Okay.
And then there's the assembler, and this is for your block engineer. This might be for your project lead. This might be for your chip architect. This is the person who's going to make sure that those circuits, that those blocks are going to work in all of the environmental conditions that they need to do. If you're doing any kind of ISO certification on your block, sometimes it's a brand new concept, but they start needing this ISO certification, then as part of that certification, what you need to do is be able to run a whole series of tests that the standards say that you need to do.
Sure.
And so it's the assembler and this last one, the verifier, and again, that's the new kid on the block. It's going to help you really get your circuit ready to go to the standards committee and say, okay, here's our circuit, here's all the tests that we've run, here's the status of them, here's all of our documentation. Okay, we want ISO certification. And that can mean a lot for an automotive part or a medical part, something that you really need to make sure is going to work all the time for the rest of its life. You don't want to be sued in the end.
No, no one does.
No, not at all.
All right, Steve, what happened to the old tools? Did you guys have an estate sale or something? Should I panic now?
You have been a Cadence customer for a long time, haven't you? Well, I've got good news, Amelia, on that front. Actually, the former tools, what I kind of call the classic ADE tools, they're alive and well.
Good.
So they're just fine. They've been updated with bug fixes and so on. So as a customer of our new IC617 release, the good news is you have your old ADE tools there and they're ready to go for you. However, we do have the brand new ones kind of on a parallel track.
Oh,
so when you get to a point in a project where you've got a new project start, maybe you've got some new engineers who are coming online, then you can start looking at the new tools and start kind of getting your feet wet with them, but not interrupt any of the design that you've already got in flight.
Excellent.
It is worth noting, however, there are some new things that are in the brand new tools that we're not backporting.
Oh.
So as I talk to you more about sort of what these products are doing, I'll try to point that out to you. I want you to always know what could be in both places, what's only going to be in the new place, so that you're well versed in what the new tool can do and what the old ones might not be able to do.
Okay, great. So what is new exactly?
Okay. Well, the biggest new thing is really a new centralized data view that we're using to store all the information in. In the classic tools, the databases would be in different kinds of formats. And so if you wanted to move from one tool to another, it was very difficult. But what we've done now is we've created a brand new cell view. It's called Maestro.
Okay.
And the new tools are all going to share information from that central database.
Ah.
So now, if you're in the Explorer, now you need to move up to the assembler to do multitest, it's easy to do. If you need to run some variation analysis on the Explorer and then send it into the verifier, it's easy to do. They're all reading and writing from the same location.
Gotcha. So, Steve, how easy is it to get to the new storage view?
Great question, because I know a lot of our customers have gone through transitions in the past that haven't been very easy.
Yeah.
But we really wanted to make this simple. So it really is nothing more than simply opening up the new tool, opening up the former database. It opens in the new tool, and when you save it, it's now the Maestro view.
Oh.
And you can bring this information from either the ADEL world, or you can bring the information in from the ADE XL world. So
Okay.
they both work, and it's nothing more than that. If you do find yourself, okay, let's say our design team has tested it, they like it, oh, you want to go kind of full forward on this one, we do have routines that can go ahead and convert an entire library for you.
Oh, cool.
But just as you're getting started, getting your feet wet, it's easy. Just open up the old, save it as the new, and away you go.
Brilliant. All right, so can we dive down into some details about these tools
Love
you
to.
mentioned? I think maybe Explorer, was that the first one?
It is. And so Explorer sort of starts us off. This was, again, remember, we were thinking about the circuit design engineer, someone who needs to get things off the ground quickly. They're all about performance.
Yeah.
They don't want to be overloaded with too much stuff, but they want to have enough stuff in order for them to get their job done. It's always this fine balance between too much and just the right amount.
Right.
So one of the big changes that we made here was we went ahead and we put in Monte Carlo statistics and corners analysis. We went ahead and put those in this base level. A lot of our customers told us that today the ability to run statistics, running the corners, is a basic thing that they do all the time. So we needed to put that into the basic tool. But along the performance lines, what we did was we went ahead and we put in an interactive Spectre simulator mode. And what this allows engineers to do is to make quick changes. The simulator runs in the snap and you see the results right away. There's a lot of the overhead we took out of the mix.
Nice.
One of the other things we wanted to simplify, it's the performance and the simplification. We have a rather extensive schematic use model now, where engineers can put waveform balloons, they can be working on their schematic, they don't have a lot of windows hanging around.
Nice.
Everything gets very centralized, and you see what's going on. Again, think of the mindset of your guys who are I just need to get this thing working. Don't give me a lot of extra hoo-ha. I just want to see
Right.
this thing. And then last but not least, which is I think is a really great feature, is a new feature that we're highlighting from Spectre. It's called Spectre's Checks and Asserts. And really, it's for finding glitches. And this is something that I know your engineers spend some time on.
Yeah.
They run the simulation, and then what happens, there's a glitch somewhere. They got to go find it.
Yeah.
But it's not very easy. This new feature that's built into the Explorer, and it's built into the Assembler also, will go ahead, find those glitches during the simulation, store them off to the side, and then your engineers can come back, look at them, find them. They'll be taken to the place in the database where it occurred, what happened, and get that information immediately. So they don't have a big problem of trying to go and find those kinds of things.
Yeah.
So really, performance, ease of use, simplicity, that's what the Explorer is all about.
Excellent. What about assembler? I think that might have been next.
Very good. Great memory, Amelia. The key with the assembler is you now move up to the assembler, and now you can bring all of those individual tests that you've been working on in the Explorer, you bring them together, and you can start testing them against each other.
Okay.
A lot of times what will happen is one block will compete with another block, and you need to bring them together, see where they're competing, and then be able to balance the blocks so that you can meet your specs. But, you've got these two competing things that are going.
Right.
So you try to find the middle ground, and that's where the assembler really is coming to help. One of the cool new things that we put inside of it is really this idea of a verification plan. And that is bringing all of your tests together, being able to write conditional tests. So run this first. If it passes, then run these 5. Take this value out of these 5 and put it into the last 5, and away I go. For some of our customers, if the first one doesn't run, there's no sense in trying to run the next 15.
Right.
All I did was use up all of your simulation licenses, and then you call me and you yell at me. And
Right.
I don't want you to yell at me, Amelia. So I'm trying to make it easier for you. So the MIDI verification plan will help with that. You don't have to run simulations when you know something has gone wrong inside of the circuit. Along with that, we've also put in some new scripting. I know some of your folks, they like the GUI, other of your folks like to work on the command line.
Right.
So there is some new scripting that's in there, very simple to do. You don't need to be a skilled programmer to figure it out.
Excellent.
And away you go. Then the other thing that we did here is we looked at some of what was previously in our ADE GXL, and we went ahead and said, some of this technology now is not so fancy. It's really everyday kind of stuff.
Mm-hmm.
And that's what we did here. We went ahead and we put in local and global optimization. So that's not a special license anymore. It's just part of the assembler. So if you're trying to center your design, or again, you've got competing specs from 2 different blocks, it's the optimizer that could kind of come and help you figure out what that middle ground is going to be.
Cool.
The other neat thing here, and again, my simulation marketing people don't like me to tell you this, so it's a secret just between you and me, Amelia.
Okay.
However, we have a feature in there called Worst Case Corners, and this can basically look at many, many corner files and develop, instead of you running 500 of them and needing 500 simulations to go through them, we can go ahead and we do a minimum amount of simulations, and we can start to hone in on what the worst corners are actually going to be for you.
Cool.
So it's going to save you some sim time, it's going to save you some performance, and it's pretty easy to set up. So if you're familiar with using our tools and setting up corners, which I know a number of your engineers are, to put this into play is really, really simple. And then last but not least is we can migrate designs.
All right.
So in that process, when you were working earlier, you were kind of working at a 65 nanometer, and you were then going to go down to a 28 nanometer.
Yeah.
And that's where we stepped in. We knew your designs just really needed to be scaled. Your layout, you're going to need to redo that.
Yeah.
But the front-end designs, your topology was all the same, so we have an easy way of scaling that for you, and then recentering your design so that you're still meeting your specifications. And again, that takes out a lot of the trial and error.
Yeah.
And the last cool thing, if I can tell you, Amelia, remember when your engineers were learning how to use ADXL and they were all kind of, let's see, what's the word? Complaining?
Yes.
Yes, complaining about the usability, but they got over the hump. They finally learned how to know and love it. So for good or for bad, the assembler looks exactly like the ADXL.
Oh, okay.
So for your folks who took the time to learn XL, there's not a new tool for them to learn. When they bring it up, it's going to look just like XL. Now, they may still yell at you and me, and that's
Probably.
okay. You have my number, but I'm hoping that will soften the blow a little bit.
All right, so you also mentioned variation option. Now, my designs, I have a lot of variations, but I'm not sure if that's what you mean.
The designs are the engineers, Amelia.
Well,
Basically, the variation is when the real world meets the ideal world.
Okay.
And the real world, when you do layout of a design, says, well, what you thought was going on in the schematic isn't really exact. It's not always going to work perfectly. specifically, there's variance in terms of the way it's manufactured.
Yeah.
And you have to take in that variance in terms of the way it's being manufactured. You have to bring that back and detect whether or not those variances are going to be a real problem for you.
Sure, yeah.
So some of this technology, we'll go back in the Wayback Machine for a moment. It was concentrated in our former classic tool called the ADE GXL.
Okay.
What we did here is we moved that into either the assembler or here in the variation option.
Okay.
And so some of the key bits of technology here are for all of our customers now who are going into advanced node designs on FinFETs. And it's a new world for a lot of folks. I know that you guys are thinking about it. There's some expense to going to FinFETs, but I know you guys are thinking about it. And the way that you approach Monte Carlo statistics with those types of designs is different than it was previous generations. So we've got some great technology that we worked on with a foundry to look at the device physics of FinFETs and to be able to give you great performance on running Monte Carlo statistics now.
Nice.
Where you can do with a minimum number of runs, you can certainly tell what's going to go on inside of the design. A lot more than what you've been able to do in the past. The other thing that we've done here is as people, again, are moving to these very small nodes, you're moving kind of away from the traditional corners world and you're running into a lot more statistics. And you really need to look at the statistical distribution. So what we offer to folks is you can go ahead, run your statistics, and then what we do is we look in the tails, basically, of the statistical distribution, and we can take out samples and we can make corners for them.
Oh.
The reason why your guys are going to like this, I think, is because rather than having to wait and run long simulations on Monte Carlo, they can go ahead and get these corner files, test these against their design, and see, hey, are we in spec? Are we close to spec? Are we out of spec?
Right.
Because you know at least these corners are going to kind of represent your worst case kind of a world. If you can design within what their spec limits, if you will, then you know that probably your design is going to be okay. You may still need to run a full Monte Carlo regression kind of at the end.
Yeah.
But at least this gives your folks a lot more ease in terms of the design of everyday circuits. And then the last one is really, I think, is a very cool feature. It basically allows you to find the bad guys inside of your design.
I love that.
So the ones who are the components that are contributing the most variance to your design, you want to be able to find out where they are, which ones at fault, and then be able to kind of hone in on that device and figure out what can you do to lessen its impact on your overall design.
Yeah.
And that's really what the statistical sensitivity and mismatch is all about. It's for finding the bad guys in your design. I don't want to say shoot them because that's kind of violent, but you nullify them.
Okay.
However James Bondian you want to do with that, it's up to you. So.
Excellent. All right. And lastly was Verifier, right?
Right. And this is the new kid on the block. And this is something, we've been doing this for a long time, but this was something that our customers are now kind of coming into their own on. And the concept is fairly simple and straightforward, but it's hard to do with analog engineers. And that is making sure that all the moving parts in the design are coalescing into one grand plan.
Excellent.
A lot of times, and I know at your company, you work with a lot of Excel spreadsheets and you have to, call people up to get them to update them and everything else like that. This world is integrated into Virtuoso. So that whole overhead of, gosh, I wish the guy would tell me what he's doing. No, from the verifier, you'll be able to see what they're doing.
Excellent. Okay.
So your grand plans can be placed in here. You can put in all of your specifications. For an example, let's say that you have a power budget for the analog portion of your design. And typically what will happen is your architect gives everybody a little bit of the power budget, and then they have to go and design to that. Well, what the verifier will show you is all of the engineers who are working on parts of the design, their specification for the power budget, and whether they're meeting that grand spec or not. If they're not, you can go ahead and contact them. Hey, Joe, look, you're using a little bit too much power. Can you ramp it back a little bit?
Yeah.
And he might say, look, I can't. What can we do here? Well, Julie isn't using all of her power because I can see that through the verifier. Maybe I can give some of the power that Julie has. I'll give that over to you. We'll balance this out and we'll be good to go for the circuit.
Yeah. Okay.
So rather than hoping that you can have that conversation after everything's broken,
right,
we'd like to have you have that conversation during the process. And here with the verifier, we can kind of help you do that. So it's a easy to use dashboard. You can see what's passing, what's failing, how much of your specs are even covered by tests. So a lot of this fumbling and game playing and I don't know, and did he go on vacation now? What the heck is going on with his design? we'd like to take all of that indirection out of the system and let you have sort of on a daily basis, see what's going on in your design world.
Excellent. So, Steve, I have the old tools and all the licenses. Am I stuck?
No. But you know what I'm going to say, Amelia. They're new licenses.
Oh, all right. That's fine.
They're new licenses, and maybe I'll let you work with the salesperson in terms of how much they cost.
Okay.
But they are new licenses. However, yes, even though they are new licenses, what we are allowing folks to do is use backwards rights.
Oh, okay.
And so that means you can have a new license, but still be able to use classic ADE tools if you want to.
Okay.
So for instance, as you can see in the picture, let's assume that you have an assembler license. Well, you can run the assembler, you can run the Explorer, you can also run ADE XL, and you can run ADEL with that license.
Okay.
So even if you bought the new tools and you have designs in flight, don't worry, your old classic tools will still work. And then as you start to migrate over to the new world, away you go.
Brilliant. All right. So, can you frame the big picture here for me?
Sure. So Cadence has been in this business now for almost 25 years. We've been doing analog design. And really, as our tools have grown over the years and we worked with all of the world's engineers on analog design, this is really just the next evolution in what it should be. We understand analog design. We understand how to bring analog design forward. And these new pillars of design, the Explorer, the Assembler, and the Verifier, we think are really a game changer. We really can elevate where analog and mixed signal design is going to go for the next generation. And so the classic tools are still around. Don't panic. But we think as you start to see what we're doing in the new world, you're going to like it a lot.
Excellent. I like it already. Well, Steve, I think that's all I have time for today. Thank you so much for joining me.
Thanks, Amelia.
And before we go, don't forget to click that link. There you can find out even more information about Cadence Design Systems' Virtuoso ADE Product Suite. For Chalk Talks, I'm Amelia Dalton from EE Journal. For more Chalk Talks, check out EE Journal's On Demand section or head on over to YouTube, keyword EE Journal.